Okay, so what this video is going to be about is my NickRGB and ROYGBIV color formats, along with a new revision to them. I'm going to share the source, and then we're going to look at some more my latest neural network videos. So, to describe what these color formats are doing, I've got some images from my dad's telescope and from NASA. And to start, we're going to look at these images, M33. Okay. So this is an image of M33 in NickRGB. And what's special about what NickRGB does is it creates a lot of lines or stripes. And so this is hold on. Let's start with this one. So it creates a lot of lines or stripes. So you can see here, there's a lot of lines. I call these stripes. And the data in this image is grayscale. And so what we're seeing is like a topology, kind of like a topology graph of the data, where lines are being drawn as the data changes elevation. So this is what NickRGB looks like for this particular space image of M42. And then I've added a new feature called striping, which causes additional stripes to occur. So this is stripe of 1, which is the default. This is stripe of 2. Then we've got stripe of 10, stripe of 20, stripe of 50, stripe of 100. Okay, these are low resolution images of the same thing. This is 1, 2, 10, 20, 50, 100. Now this is ROYGBIV. ROYGBIV has far fewer stripes. There's far fewer detail in terms of stripes. You can see this has maybe 1, 2, 3, 4, 5, 6, 7, around 8 colors, so there'd be 8 stripes. And you can see in the center, it's basically all blue. There's no stripes. Whereas with NickRGB, there's lots of stripes in this center area. So now we're going to increase the stripe count. ROYGBIV 2 stripe, 10. It's starting to look more like NickRGB. 20. 50. 100. And so ROYGBIV 100 isn't so different from NickRGB 1. It is still not as detailed, but you can see there are a lot of stripes. Okay, so let's look at the next set of images. So that was taken with my dad's telescope. This one is also taken with my dad's telescope. This is called M33. So this is NickRGB 1, 2, 10, this one is 20, 50, 100. So at NickRGB 100, there's so many stripes, you can't really see a lot of objects. So now this is what the low resolution image looks like. This is ROYGBIV 1, 2, 10, 20, 50, 100. Okay, let's look at some more images. These were from some sort of NASA instrument. This is of the sun. This is NickRGB 1, 2, 10, 20, 50, 100. This is ROYGBIV 1, 2, 10, 20, 50, 100. Okay, here's another NASA instrument. So this image of the sun, the data is so tessellated that there's lots of stripes. It's hard to make out what's going on in the internals with this full signal. So this is NickRGB 1, 2, 10, 20, 50, 100, and now ROYGBIV 1, 2, 10, 20, 50, 100. Okay, so that's basically what ROYGBIV, stripe, and NickRGB are about, is drawing stripes and lines on grayscale data. So let's look at the code. So I've got, this is a C++, obviously. We load a fits image. This is a typical fits reading routine. We have a vector of floats. We read in the floats from the fits, and then we have a loop. For each stripe we're going to write. We have a save to file colorize with NickRGB and ROYGBIV. So save to file colorize, this is a typical free image writing routine. The first line is we declare a vector of int32s called converted, same size as our float data, and then I call this function float space convert. So in float space convert, I have this thing called a view window. By default, the view window is 0 to 1, which is 0% to 100% of the image data. So then there's a function convert to grayscale, which converts the float data into a percent, which is between 0 and 1. And then for NickRGB, we get the int maximum, get rid of the alpha channel. For each pixel, convert to grayscale. And this is the NickRGB transform. Super simple. It's a linear transform. It's just percent times int max. And then store the pixel data, so the converted. For ROYGBIV, ROYGBIV is a lot more complicated. It's get convert to grayscale. Go through this routine, which I did not write this ROYGBIV routine. I got it online. So writes ROYGBIV, stores the pixel data, Let me go back, get the bytes, write the bytes out, and that's it. That's all that's going on. Okay, so now let's look at my neural network program. So this is the neural network viewer. So every step, there's 15 steps a second. It trains the network, and then it sets it to texture. And then it updates the training data, it updates the captions. So set to texture. I call float space convert. Pass in all the weights of the network. All the weights of the network are just one big array. It's stored in one big array. I pass them all in. I get them out, converted weights. I pass the converted weights out and fill the text box with them. That looks like this. And that is what we are seeing. The neural network data is all grayscale. The weight data is all grayscale. And so let's look at what I've been, my latest series. Okay, the captions have changed a lot. So what's going on here is we're running 15 ticks a second. We're training mince data. I can't run all of the mince data at once 15 times a second. So I run 100. And then it calculates the misses, the radius, and then it gets the next 100 data. And then it gets the next 100 data. Each step, there's a new 100 data. And so what this training data is in the mince data set, there's 60,000 images. But there's not an equal amount of images for each digit. So what I do is I create what I call a digit stripe, where I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I keep striping all of the digits until all of them are present in this vector. And then in order to do that, it reuses some of the images in order to complete stripes. And so there's a total of 67,420 total samples in this training array. And then this is the test accuracy of the test data, which is 10,000 images. It's 87. This is NickRGB color mode. The total weights in this network, 47,904. There's 262 nodes. The shape is 784, means 48 by 3 hidden layers. The output size is 70. So I'm going to talk about the output size. So in ROYGBIV, it looks like this. You can see there are these areas here. I'm not one-hot encoding. My encoding scheme is something I call curve encoding. And you can see there is clearly 10 output areas for each digit. And this is the output layer area here. So let's increase the stripe num on ROYGBIV. You can see we're getting some detail in the input layer, whereas on one with just the default one, there wasn't any a lot of detail. I'm going to keep increasing the stripe num. I'm not sure how this is going to look on YouTube. I think I'm going to start putting my videos somewhere else. I don't think this is going to really render on YouTube very well. So this is ROYGBIV with really high strike nub. You can see there's a lot of detail. You can see there's some stuff going on in the hidden layers, the blinking area here and over here. This is what it looks like in NickRGB. You can see there's movement. It's like the train is like morphing and it's trying to shape. And all the data is grayscale. All it's doing is drawing lines and the relationships. It's a linear function. Okay, let's see. Go back down. Some of these networks. So I'm going to be trying to create more what I call problem-solving shapes in this input layer. I haven't really attempted to do that at all with this series. Okay, so with Series C, this is what happened with Series C. It turns out those networks started exploding at a really high rate because it turns out there was an error in my batch propagation. There were some other errors. So what I did was I fixed these errors, I branched, I fixed these errors, I did some more software development, I did a lot of refactoring. And so I'm going to be creating a new series, problem-safe series, before long, where it'll be running on mints. We'll see how it works, what it looks like. This series, I wasn't explicitly trying to create problem-solving shapes in the input layer. There are some sort of shapes. Anyways, that's how I'm going to be publishing my this fits converter on my GitHub, which is going to be listed on the YouTube caption. So that's what's been going on with NickRGB and ROYGBIV.